Dear students, welcome to SCPS online live class 8 English version. This is your Kamrul sir. Alhamdulillah, I am fine. I hope you are also fine by the grace of Almighty Allah. Dear students, in our previous class we discussed some theorem of circle, theorem 1, 2, 3 and an example. Now today we will discuss exercise 10.1. In our exercise 10.1, you will get 6 problems. Now today we will discuss only two problems, problem number 1 and problem number 6. Among these 6 questions, 1 and 6, these two are most important for you. So it will be better if we discuss 1 and 6. And dear students, to solve 1 and 6, we can apply our theorem number 1. Now we can start, and at first we can memorize. We can revise theorem 1. Look, this is a circle with center O, and suppose this is a chord AB, and suppose this M is the midpoint. M is the midpoint. So this is our information. O is the center of the circle, AB is a chord, and M is the midpoint of the chord. Now our theorem number 1. This is said that if we join these two on, now if we join these two on, that means center and midpoint, then we will get a line segment. This line segment, it will be perpendicular to the chord. That means it will be 90 degree. That means OM perpendicular AB. So when center and midpoint of any chord will be joined, then it will be perpendicular to chord. That means here it will be 90 degree. There 90 degree, also it will be 90 degree. So this is our theorem number 1. So conversely we can say that if this is a chord AB and suppose this is a center O, conversely, now if we draw a perpendicular on this AB, look, now we try to draw a perpendicular on AB. Suppose this is 90 degree. We draw, suppose at the point E. Then this E, it will be the midpoint of the AB. That means if we draw 90 degree, it will be midpoint. Why? Because in our previous case, we know if we join center and midpoint, it will be 90 degree. So if we draw 90 degree, so other case we can say it will be midpoint. Clear? So this is our theorem number 1, and this is the converse statement of theorem number 1. By using these two information, we will be able to solve our problem exercise 10.1. So today we will solve problem number 1 and problem number 6 by using our theorem number 1. Now what is said that problem number 1? If two chords of a circle intersect and they are bisect each other. Bisect means two equal part. Other their point of intersection, it will be the center of the circle. That means if two chords, they are intersect a point and they are also bisect each other, this meeting point, this intersecting point of the two chords, it will be the center. We have to prove that. So dear students, at first we can draw our figure. Suppose this is the circle, and suppose this is the midpoint. Suppose AB and CD. Suppose AB and CD are two chords, and this E is the intersecting point of these two chords. Now we have to prove that this E is the center of the circle. So we can draw it at first, particular enunciation. This is the short form, but you have to write full form. Clear? Particular enunciation. Now let AB and CD are the two chords of a circle meet or meet না দিয়ে আমরা বলতে পারি then we can say of a circle bisect each other, they are bisect each other at the point E. So at the point E they are bisect each other. Now it is required to prove that it is required to prove that, so it is required to prove that E is the center of the circle. So this is our statement. So what is the particular enunciation? Particular enunciation means you have to explain the problem according to your own process. This is our particular enunciation. This is general enunciation and this is our particular enunciation. Here we can use A, B, C, D. Clear? So E is the intersecting point. At the point E they are bisect each other. That means AE, BE equal and CE and CD are equal. So E is the midpoint, bisect each other. That means E is the midpoint of AB and CD also. Now we have to prove that E is the center of the circle. Now dear students, we can write construction. Suppose O is the center of the circle. Now we can adjoin O and E. Now we can suppose this is O and suppose this O, this is the center of the circle. Suppose, not E, suppose O is the center of the circle, but remember we have to prove that E is the center of circle, but now we can suppose O is the center of circle. Now join O and E. So this is our construction part. So this is particular enunciation part and also a construction part. Now we will go to the our proofing. Now dear students, proof. Look dear students, here E is the bisector, E is the midpoint because they are bisect, these two chords are bisected each other. So E is the midpoint. So if E is the midpoint, so OE, we know in our theorem 1 when we join center and midpoint of a chord, then they form 90 degree. That means right angle, perpendicular. So here E is the midpoint. So OE, it will be perpendicular to AB. Also E is the midpoint of CD. So OE, it will be the perpendicular on CD. So we can write, since OE is the midpoint, since E is the midpoint of AB and CD, therefore OE perpendicular AB, OE perpendicular AB and OE perpendicular CD. Because E is the midpoint of AB, so OE perpendicular AB, and also E is the midpoint of CD, so it will be OE perpendicular CD. So we can write, if OE perpendicular AB, that means angle OEA, it will be on right angle. That means you can say 90 degree or on right angle. Suppose we can say this is one right angle. Also you can say 90 degree. And angle OEC or OED. Suppose we can write OED. It will be one right angle. Look, OEA, this is one right angle, and OED, this is also one right angle. Is it possible? In the figure, if we send, is it possible? No. So what will be the answer? So here AB and CD intersecting line. Look, here AB and CD, they are intersecting line, not parallel line, intersecting line. So angle OEA and angle OED cannot be equal. Since these two chords are intersecting, so they are not parallel. So we can say OEA and OED, these two angles cannot be equal. Here we can say this is one right angle and this is one right angle. But our figure said that they cannot be equal. So what is our wrong process? Our wrong process, if we say O is the center, this will be our wrong process. So we have to say E is the center of the circle, then we will get the correct answer. So now we can write therefore no point other than E, no point other than E can be the center of the circle. So to solve this problem, must be we have to say that E is the center. Therefore E is the center of the circle. So proved. So we can say E is the center of the circle. So we can say that only E, it will be the center of the circle. Then this problem, it will be solved. So here E is the center of the circle. And dear students, you know only diameter is passing through the center. Then it's divided by two parts. And O, this is the midpoint of the diameter, and also O is the center of the diameter. So you can say when two chords are bisect, obviously it will be the center. Otherwise it cannot be possible. Clear? Now dear students, we will go to the problem number 6. A chords AB of one of two concentric circle, that means their center is same. It is called unit center. Concentric circle, or you can say unit center. Concentric circle intersect the other at C and D. A chord, it will be divide the other circle C and D. Now we have to prove that AC equal BD. So at first we can say our problem as a geometrical figure. Our problem number 6. Suppose this is a circle and this is also another circle, and this is the center. So both circle, their center is same. This is called concentric circle, or here this center is called unicenter. Now suppose AB, A and B. Suppose AB is a chord of the greater circle. We can say this is A CB. Here C is the another, so we can write another. Suppose F AFB. We can write as a name for the circle, greater circle, AFB. This is the name of greater circle. This greater circle AB is a chord. Now this AB, this chord intersect the circle, inner circle, smaller circle at the point C and D. Suppose this is the point C and suppose this is the point D. Clear? Now it is required to prove that this AC equal to BD. We have to prove that. Now for the smaller circle or inner circle, we can say this is CED. The name of the circle we can say CED, or you can take another name. So at first write the particular enunciation. So here already AB is a given, so we can write AB is a chord of the circle AFB with center O. It is intersect the circle CED, at the point C and D. So the chord AB, this is intersect the circle CED, smaller circle or inner circle, at the point C and D. Now it is required to prove that AC equal BD. AC equal BD. That means this part and this part, this will be equal. So this is our particular enunciation. Now construction. We draw O, suppose M. We draw OM perpendicular AB. That means this one perpendicular AB. This is our construction. We draw OM as a perpendicular of AB. So this is our construction. This is our particular enunciation. Now this is our construction. Now we will go to our proof part. This is our problem number 6, exercise 10.1. Now dear students, look, proof. Here OM, look, this OM, this is perpendicular. By construction we draw perpendicular. So this M will be midpoint of the chord, remember. So we can write here OM perpendicular AB. Therefore M is the midpoint of AB. Look, OM perpendicular AB. So this is indicate M is the midpoint of AB. So we can write therefore AM equal BM. Now also look, also OM, this is perpendicular of CD, because CD is a chord of the inner circle CD. This is a chord. So we can say OM also perpendicular CD. So OM perpendicular CD. So therefore M will be the midpoint of CD. Clear? So directly we can write, now directly similarly we can write Cm equal MD. Clear, dear students? Because this M it also the midpoint of CD, so Cm it will be MD, as like that. Now we can write, if we subtract Cm, look, if we subtract Cm from AM minus Cm, and if we subtract MD from BM, if we subtract MD, now look, AM, this one AM, if we subtract Cm, so it will be SC. So if we subtract Cm from AM, our answer will be SC. And if we subtract MD from BM, our answer will be BD. So we can write BD. Now look, SC equal BD. So we can say proved. So very simple, dear students. Now if you try, you will be able to solve our remaining problem 2, 3, 4, 5. So problem number 2, 3, 4 and 5. These 4 problems, it is your homework, and I hope you will be able to solve it. So at first try to for better understanding problem number 1 and 6, then you can try to solve remaining one. Okay, dear students, thank you very much. No more today.